Hi, Gary Harrington. I'm doing integration. I'm English. I watch the game as well. Looking forward to seeing Romania in the semi. But I wanted to show this one first. This is the Qlik Talend Cloud. This is just to give you a concept that there's an awful lot of stuff happening. We're bringing all the analytics, the stuff from Talend, the stuff that was formerly Qlik Data Integration, all into this single place, which is Qlik Talend Cloud. And you're going to see some of it today. But I'm going to just whiteboard up the bit that you're actually going to see. And this is the kind of key components of the Qlik Talend Cloud data integration solution. And it's really important to understand this picture, because if you look at it, it's really hard to work out what's going on in the background. Yeah? And it's really important to understand the boundaries between what happens at Qlik in the SaaS solution and what happens within the customer landscape. So, customers will have source databases, and they will have target databases, on-prem and cloud data warehouses. And what we need to do to support our solution is we need a Linux box and a server. So this is our replication engine. This is the thing that helps deliver data from all your sources to your targets, or the customer's targets. Yeah. And there will be source tables. And the way our solution works is we perform an initial unload of those tables from the source databases, and we deliver those tables to the target databases as a kind of load starting position. And once we've done that, we have different interfaces for all the major databases to hook into the redo logs and continuously listen to transactions as they're arriving on the source databases, and give you a continuous feed of changes. So that's all the inserts, all the updates, all the deletes, table structure changes, even new tables. All of these are constantly flowed from the source to the target. Now this is what happens within the customer side. Right? I'm doing this because this saves me an awful lot of questions afterwards. Okay? And this is what happens in Qlik. So, and the main aspect of this is that, well, a key feature of what we're doing here is we're doing this solution is a change data capture solution, which you guys have probably heard about, and people always talk about it as being a great solution for delivering near real-time data. But it's not just that, and when we think about this, when we're looking at the benefits of it, it's also low impact on the source, because you're only looking at the transaction log. So what we're talking about is a solution that delivers a synchronized copy of your data in your target, but with very low impact on the source, guaranteed delivery because we're getting every single change from the source. You don't need any agents because we have a server here, so you don't need anything running on your source databases. And as you'll see, a key kind of tenet of everything we do in these Qlik integration projects is as much automation as possible. So wherever we can, it's no code. And you'll see some of the widgets we do for that. And so this is the Qlik Talend Cloud environment. So we've seen what's happening on the customer side. And to make everything super secure, is the connection between the gateway that runs on the customer side and us is an outbound connection, the gateway management piece. And we do two things I'm going to mainly show you today. We send instructions to create data pipelines to create these replication flows that I've shown you. And once we've done that, again, as much as we can in a no-code environment, we give you push-down SQL to let you transform that data in the target. Alongside that, you have some nice stuff that you would expect to have in an environment, users, role spaces, access controls, that sort of thing. And if we get time, we maybe see a little bit around data catalog and lineage type stuff, and the monitoring. Okay, so this is the solution you can see. And I'm going to go straight to the environment. And this is it. So it's the same as what Lucas saw, but this is actually a rolled out tenant. Lucas was on an early adopter thing, early access. And a little bit like Lucas, I've only been able to test this on the early access until this morning. This is the first time I've had it in my own. It's brand new. So I have been able to play with it, but this is an environment for using for the first day of play. So, what you do in QCDI is you start off with connections to your databases. So these are the different connections. Should be able to see that. Just a typical sort of ODBC style connection to a database. That's all you need to set up the connection. Behind the scenes, there's some complex stuff going on about the authorization levels that you need, because we're accessing some pretty heavy stuff in the database because we're getting straight to the transaction. But in terms of creating a connection, it just looks like many you've used before. So if you have the access, you can create this kind of connection. And once you've created the connections that you need for your different databases, you can create a data project. And this is going to be a project that, as is shown in the whiteboard, helps you move data from a source into a target, in this case Snowflake, and then once it's in there, transform that data to support whatever use cases you might have in that space. And so here, you see there's just a bit of clicking around to select the target, and this is the particular area that you've organised for, again, to manage access controls between the spaces, which QlikSense Enterprise customers know about, and you create a project. And this is like the palette that you work in. And first thing I'm going to do is I'm going to create a prefix. Now, in the background, this project creates an awful lot of tables, views, etc. In specific schemas. So it's nice to be able to identify them. So I'm going to call all my schemas request_. And then this is how you bring data into the system. So I am going to access one database called sales. And this is a list of valid connections, not all the connections, but the valid connections for a source. Put this one in. And instead of having to write the code, having to understand the database, deciding when is a good time to access the data, getting approval to access the data at a particular time, all we need to do in the solution is know the name of the schema, and then we can pick the tables that we want to be within our pipeline. So I'm going to select all these tables. And I've created a pipeline for that data. We'll see exactly what that is in a moment, but within this pipeline you can do some transformation. You can see we've pulled in the tables from the source. It's automatically got the metadata for the columns that we need, and this will all be created automatically on your target. You can create new columns here. You can do some quite complex functions here to create new columns and update columns. And because I'm going to Snowflake, I tend to do this because it makes the SQL look a bit better, and that's turn everything into uppercase. That's for the dataset names, and I'm just going to do the same for the column names. As you can see, there's an awful lot of other options in here. I'm doing the most simple one, just changing the case to uppercase on every column. Okay, so I'm going to ask it to prepare that, and by preparing that, it's creating the schemas, the tables, and the SQL. You'll see what I mean by that. But this is just from one database, so I can bring you some information from another one. My first database is the famous, notorious Northwind database with some sales data. And this one has some, Thanks Lucas. To re-log in. So it's lost that, start on again. So onboard some data. So there's two separate databases, one with sales information, one with service contacts for the same products. And the second one is on SQL Server. And again, similar type of connection. It says log-based here because we can use the log-based, the native SQL Server log, or the Microsoft SQL Server CDC function of their own. Log-based is better. And then you select schema. And if anyone was following the first time we selected the tables, this time I'm going to say I don't care which tables are in the schema, I just want all of them. So now it's creating a pipeline for however many tables you want that source database. You're talking hundreds of tables. Just with those clicks, you have a synchronized copy on your target. And one, going back to the original picture, that you can be comfortable is having the minimum impact on the source because you're only reading the transaction log. So you're not running nightly extracts to move it to your target data warehouse. You're just continuously listening on that log, one single client, minimum impact. Okay. So we'll prepare those as well. So it's picked up the ones that are valid for preparation. And while it's doing that, we'll run this here and have a look at it. So there are two windows, the design, which you've already seen, and the monitoring, where things start to happen. And in this case, we should have view the logs. And what you can see in here, I don't know if there's any error message that'll still say it. This is the Opportunity product that Peter was talking about right at the start. So this, again, similar to what Lucas was saying with the indexing and chunking product, is something that's been running for a while, and we're integrating it into this whole thing. So you can see it's loading some tables. It's a little bit slower this one because we're talking to Snowflake. And if we go back to the design view, just in order. Originally when we were designing it, we had this tab here, data sets, but now that we've actually run it and created some tables, we've got some physical objects created. And now this is what we need to understand to go back again to the original picture. There's two things happening. There's an initial copy, and we can see that now. So this is the data, and then changes as they occur on the source. Here, that's the format. Over the years this product's been in operation, we've created some really useful metadata here that go with each change. You'll see that when we put some changes through. And if we go back again, because there's no changes yet. Hopefully my changes are live, so good. This one's ready to run. So this is the service calls database that we're just looking at. So I'm just going to change a couple of things in here. You see I'm doing this while the thing's still loading, because you don't have to stop the database. This thing will understand that you started your synchronization, and so it will start saving these changes. Yeah? Let's delete that one. Save these changes. What is that? In the service reason table. And if we go into here, because it's running, it's gone straight into the monitor view, and you see those two changes are already there. So if we go back to the design, and look at these physical objects again. So like I said, there's two tables for each requested table. So with the service reason here, this is the initial load, right? So this hasn't changed, you just do this once. It's a full unload of the table, bulk loaded into Snowflake. Okay? But we also have this table here, that if the demo gods are working with us, we should have some information. Good. Okay, so you can see that on service reason ID 4, we have two rows, because we have the before image version of that row, and the after image version. And we also have one row here to say that service reason 9 has been deleted. But at the moment that's not so usable. That's the most efficient way of loading the data, because we take an initial copy just once, and then we're doing insert only of all the changes that are happening on the transaction log. But to make this really useful, we have this second block that was automatically created when we signed on to request those tables. And if we run this second block, this can be scheduled to run anytime there are changes, every hour, or based on external service calls, as you wish. So typically, you might roll up all your changes during the day, and then create this long, so this is what we call the write optimized storage, and then move the data from the write, or copy the data from the write optimized storage into the read optimized storage every hour, start of day, end of reporting day, whatever suits your particular use case. So we go into here. Again, you've got the data sets, which is kind of the logical version of it. And then the physical objects, which is what is actually sitting behind it. Now you see, if anyone noticed, but on the first object, it was tables. Here we have a whole set of views. Now this is because this is our first aspect of push down. So whereas that first object that you saw was a CDC solution, taking information from sources, synchronizing with the transaction log, that was a product called a Unity replicator, just for history. What we're doing here is we're reimagining a product that we used to have to create historical tables of customers called a Unity Compose. Yeah, so this has been used by many customers to build their data warehouses, and we brought those two together to make it look a kind of seamless environment. But the IP comes from the Compose product, so again, it's an established product. And you can see, if we look at this particular logical data set, you see behind it, we've automatically created the DDL for the tables. So this is the actual key storage. So you saw like five views, 2, 3, 4, 5. No, there's 6 views that you can see that are kind of published, but sitting behind them are the 3 actual physical tables. The SQL to do the load is automatically created, and the SQL to update based on changes arriving is all automatically created. Yeah. So just to go back to the start, all we've done is say, I want to connect to this database, and I want everything in the schema. And it's created all that SQL, all the target tables based on your source, ready to go. And if we run this now, and it works, then when we look at that one, I can show you what these different views are. So we put some changes for in-service reason. So service reason, we should not have number 9, I think it was, because it's deleted. Right? Okay, good. Only up to number 8. But it's really useful to know that one day there was a 9. You don't want to lose it completely, so you want to soft delete. So if you go to the history table, and we sort it, you can see that 9 is deleted equals true. So there's your soft delete. So the data's there. You can see when it happened. Right? So that this value, unknown reason, was in the database from the beginning of time. That's all we can do. And then it was deleted, soft delete at this point. Yeah? But we also made another change to number 4 here. And you'll see that this one was from the beginning of time. What's that? From the beginning of time to that, it should be this value, and then from that point to now, it's now this value. They look the same. I'm not sure why. Anyway. Let's refresh that. No, it's not happening. Okay. I'm going to put another change in just to pick that up later. So, we'll run this as well. So now you can see how you can create a pipeline from your sources, have a kind of ready-to-use historical storage for any of the apps that can access this particular database. And now I want to show you two types of transformations that we can do. The first one is the first real example of our integration with Talend. So the first of the Talend products that are coming into this flow, because as I say, these two elements that you can see here, this is a Qunity Replicate, this is a Qunity Compose, reimagined, but still with their roots in those products. And now, what's the question? Go on.
You have it here.
Yeah.
Another question, do you have as destination QVD files in Qlik
Sorry?
Catalog? As destination, do you have also QVD files in Qlik Catalog?
I forgot to mention it. Yeah, the other thing that we do here as part of this package, yeah, is we can create a project. Oh, it's coming out again. I have to go to a different tenant for that, but if I go to this one here. One of the valid targets is directly into QVDs. Yeah. So this is erroring because it's been cut off. But this is generated exactly the same way, a QVD file. It's slightly different in that the QVD that you create is not so near real time, it's 15 minutes.
That's the next question, is it CDC?
And it's CDC.
Okay.
So we create a staging in S3 with the original file and then stream all the changes into that, but then we only kind of roll them across into QVDs every 15 minutes. Yeah, it's because I was told that in order to do that, you need like a headless Qlik send tab, yeah, that generates the QVDs, and they didn't want it to kind of get confused. They figured 15 minutes is kind of a safe period for it to definitely be able to read the file before it goes back and tries to read it again. Yeah, so I don't know. No one's told me they've got any intention of making it less than 15, but normally a QVD that's within 15 minutes of your main production system is pretty good. Yeah.
But it's really incremental, or you write again the QVD every 15 minutes?
No, yeah, it adds it to the QVD. Yeah, it's an app. It's an app that reads the increments and writes them into the QVD.
It's append.
Yeah, appends it.
How does it handle changes in the table structures?
It will. The transaction log has all the changes that are happening on the log. So DDL and DML. Yeah. So if there's so the DDL is where the new tables, new columns are being added, columns changed, tables being added, that sort of stuff. And so we get them from the log as well. So they're all automatically fed to us.
Two more questions. First one, is there any way to handle really big data sets to data partitioning? Or it's just the initial plus?
Yeah, you can use the partitioning on the source, or you can create your own.
Can you repeat?
You can use the partitioning on the source normally, so if there is partitioning there, you will normally be able to use it.
Okay.
Or you can create your own kind of logical partitioning.
Okay.
Yeah. So both are available.
And the second one is, you want to connect to several thousand servers. Is there any way to automate that?
Do you mean several thousand sources?
Yes.
We're actually working with a customer at the moment that's got a very, very similar problem. Yeah. And you can automate it. I mean, basically, you would probably use the on-prem product rather than the cloud product. Yeah, but it's fundamentally the same. So you'd be using actually the same logic here. Yeah, but you wouldn't be deploying the UI in the SaaS environment. You'd be using the UI native on the server itself. But it's the same. And then you can create.
Or we have a table where you find the addresses and the credentials.
Yeah, that's right. That's what you can do, and then you can kind of pop them in. Yeah. It's the same for sort of CI/CD type solutions. You need a way of creating tasks, moving through the environments automatically, remapping connections. It does all that sort of stuff. And so in this, I'm not going to mention the customer, but it's one you all know. But they've got hundreds of servers. And so we're basically having a way of deploying the same task, the same replication, and then mapping it to the local environment on each of the servers.
Yeah, we have.
And then once they're running,
5,000 servers.
yeah, because once they're running, they're the same. Yeah, and they manage themselves. They don't, so you do have. You have the operational management getting the thing live, yeah. But once it's live, you're just monitoring it. You're not asking it to be rescheduled. You've got no kind of scheduling dependencies about when it should run, because these things just live and they run. And because it's been running a long while, it's very resilient to things like the source dying or the target being unavailable for a period, and it has a kind of buffering area that it can use until contact is re-established. So typical normal sort of communication breakdowns, it can just handle automatically. Sometimes you might need to restart it, and it might need to restart from a point in the log. But these sort of things, it's kind of dealt with most real-world scenarios in the past, because it's a Unity replicator running a long while.
One more question, please.
Of course.
In this, can you get the picture, please? In that picture?
This one?
Yes.
Oh, sorry.
We have two pipelines. You need to define each for the source.
Oh, the pipeline, sorry?
Yes.
One of these, yeah?
You have two sources and you output two QBDs. These are one QBD per pipeline.
No, you can create multiple.
I mean, if the source has 3 tables, the output will be one pipeline and 3 QBDs.
Yes. Yes.
Or 3 pipelines.
No, one pipeline and multiple QBDs within it.
You need to do something special.
Or you can do both. I mean, you can do both, but the implication is, if you had 3 pipelines, you're reading the transaction log 3 times.
And you said 15 minutes to read again the QBD refill.
To create the new QBD, yeah.
You said 15 minutes because of what?
Because the headless QBD at the Qlik Center has to read the changes, apply them to the QBD, and then restart in 15 minutes and do the same thing again. Yeah, and this could be a big table, a big file, and so in order to make it kind of predictable and safe, yeah, they want to make sure it's kind of not rescheduled while it's still working. I think.
Or even worse, to try to read it while it's still writing.
Yeah, exactly. So
Is
it's
there
to stop it getting confused on itself. Yeah, so they think 15 minutes is fine.
Is there a limit of the growth of the file, of the QBD file? If it's a big one, should be more than 15 minutes? Or should be like...
I mean, 15 minutes is the number. Yeah, if it's bigger than that, it won't work. And but there is also physical limits around the files that you can use, I think, anyway. Yes, I think we're within that. And I would guess they used that when they worked out the 15 minutes. Yeah, let's work out what would be the biggest thing we have to deal with and work backwards.
Case of SAP, you are not extracting data from the table, you have extractors, which are programs on top.
No, we have different. We have. I guess you could call it 4 different ways of extracting from SAP. We use the extractors, and the interface is the same. Just the same thing. I want this table, this table, this table. But we use the extractors behind the scenes. We use ODP. So with ODP, we have access to more objects than the extractors, things like CDS views. And if you've got an EC system running on SQL Server or something, we'll just use the basic transaction log, just like you saw there. And so it'll be a full CDC solution from the SQL Server database. If you've got HANA, this is where it's 4, so it's basically 3, except for HANA has an extra one. HANA, we can do the same full CDC if you can give us access to the file, which is where the transaction log is held. So it's not like a normal database. Normal databases, you kind of pull chunks of the transaction log from the database. But with HANA, it's a file, so that people have to give us access to where the file is so that we can read the transactions. But then it's just the same. But if you can't give us access to that, we can also do it using our own trigger functions, which is a bit like SLT, but it's from us.
So you can say these tables, we want CBC from them, and we will generate internally triggers on the SAP HANA database, and then we use those triggers to pull the data.
How do you have to use extractors? Because you have to use extractors,
No.
because in extractors you have all the logic of the...
No, we can go to the database. If people have to have the enterprise license, but if they've got the enterprise license, you can go directly to the tables on the database. The extractors is kind of like a usability feature to make it more readily available to get to those tables, but the tables are still there.
The extractors also have a big logic of how to process all the data. Otherwise, you have to do everything from the beginning.
Well, the other thing is we have a product called Qlik Talend, and if anyone's got a big SAP system, they should talk to us, because Qlik Talend is very, very useful for big SAP systems, because what it does is it creates small copies of your SAP database, any version more or less, yeah? And people use that for test data, and they use it even as, I've heard cases where people use our Qlik Talend solution to say, we've got a problem with this one customer on SAP, try and work out what's wrong, and so we'll create a database with just one customer, right? But with all the associated tables. And the reason I'm explaining that is because we use the IP from Qlik Talend in here so that the data makes sense. So that you don't have to try and work out what's happening in SAP. You can just say, what are the tables that I might be interested in materials management? And you can click on that and it'll list the materials management tables. I don't have a SAP demo for today, but we can do one if you're interested. Oh, don't do that. Again, it's not the extractor. It's directly to the transaction log and the original tables in just the way I would describe it earlier.
Okay, it's working only with tables.
Sorry?
It's working only with tables, it doesn't work.
It's all?
It's working only with tables, it doesn't work with the extractors.
No, it does that as well. No, sorry. What I mean is you can use extractors, and if you don't have an enterprise license, you might need to use extractors. And then the dialogue looks just the same, but what's happening behind the scenes is we're using the SAP extractors. If you have access to the database, we can give you a CBC solution, which looks like a normal database, not just SAP. So it's seconds all the time. Yeah. And again, continuous, and again, no jobs to be scheduled, that sort of thing. Yeah. So that's data. So we've got some data in the system now. We've done a little bit of push down to move the data around to create historical copies. But now I'm going to try and show you two types of transformation. So we're going to create a new object where we transform data. And we need to tell this object which data it's allowed to use. So I'm going to just take everything, because I'm lazy. So I want everything from those two objects, storage objects here. And I'm going to do here a silly little example where I want to know about my products. For each product, I want to know how many service contacts there are, and how many times it's been ordered, and when was the last time it was ordered. Okay, so the product is my driving table here sort of thing, and I need to link to this service contact, which if you remember came from a completely different database, and join to these two tables up here. And I'm going to use transformation flows to do this first. So, product flow. And this was Pipeline Designer at Talend, and we've taken the IP from the Talend product and turned it into a push-down SQL. Ryan will tell me they're already working on it in Talend, but they're taking it all the way now. So this thing here is going to generate some push-down SQL for you. So let's do it this way now. Okay, let's take service contact. So we're going to need service contact. But first, we want to aggregate it by product. Right, so let's find out how many service contacts there are by product. So I'm going to do accounts and product ID.
and save it. What have I done? Oh, sorry. Now what we've got here is like a node in this flow. So we've taken one table in, and we're doing some functionality which is going to run this piece of SQL on the left, and you've got like an example of what the data looks like. So we've already created the count for each product of how many service contracts there are. Okay? Then I'm going to join my order details and orders together. I'm terrible at these things. And I'm going to do, that must be order ID. And order ID. And save it. And you can see here, this is the full join of those two tables. So that's the SQL to get to this point on the flow, on the DAG, if you like. And we'll want to aggregate that as well. If you remember, my problem is I want to know how many orders there are by product, and when was the last one. So I want to group by product. I want a count by product, and I want another duration, which will be a maximum delay. So now you can see how many orders per product and when the last date was. And then we just need to say, okay, let's join. Let's go over. Let's join this. So now this demo, I'm just doing these stupid little lines. Can't join them. And so now we're taking the output, this one here, which is, I hope everyone can see that. So that's by product, the count of orders and the last order, joining it with the product itself, and we'll join it, no guesses here, it's product again, save it. You can see now, we should have an output that has all the information about a product, and at the end, there you go, the number of orders and the maximum order. And then we'll just do the, where's the other one of those? We'll join in the number of service contacts as well. And you see, as each one, I don't know if you noticed, had a little orange warning on it because the output from that box wasn't being used. So as soon as I connect it into another box, this one's now valid, but this one needs to be used. Yeah. So going to here, again, let's just join the products. And products. And save it. It's not so interesting. And then connect it to the output, and you'd think that would be okay. The problem that's still got to do there is this is an output. Because of the way the system works, everything needs a primary key. So we need to put a key on that output, and hopefully if we do that, it should say valid. Okay. So now, what this isn't is a whole bunch of different sequels to run. Yeah? This is an interactive build-up of the different SQLs that are needed to take these input data sets and create this single output. Okay? So this thing here is the one SQL that really applies, and this is the output data set that applies. Close it. data set, like the data sets you saw in the earlier block, with a whole bunch of SQL around it. But at the moment it's still a view. So this is the view, so this is what we've interactively built. Yeah, see here is all the product information, and you'll have to trust me, but this is the count of purchases, the last purchase, and obviously you can make these sensible, but that's the way that moment, but they are at the moment, and this is the number of service contacts for that product, right? So that's a view that's been created that you can use directly, but you might say that based on the way you want to manage your database, you want to materialize that view, and now the SQL's changed, hopefully, and instead of views, it now creates the tables, similar to before. So you have a current version of this table, a historical version, and so as that data, that product and its association with number of contacts, association with number of purchases, as that changes, you get continuous history. All the changes guaranteed delivery. That's one type of transformation. And now, as Lucas hinted earlier, that we now have a new one. And I'm going to use the AI function to generate some SQL, hopefully. And you could do the same thing again, because this is also kind of clever, that it will only work with the data it's got. So if I know, as I do, that I only really want to use these 4 tables here, those 3, that one, yeah, I could use it. But I'm very lazy, so I'm going to use all of them and let the AI work it out for me. So I'm going to create a SQL transformation, and it's going to be product SQL. And this little button here is the new magic thing, also Bedrock. And we could say here, let's work this out, so we want all product info. Well, we can do this interactively first, I suppose. And it tries to work out what that is, and says, you mean that? Right, okay, good. Okay, no more complex. All the product info with number of, I wonder if we do this, I'll try this before. Number of customer calls. There's nothing called customer calls in the database, so I'm not going to see if it works it out. It has. There you go. It's used that same table. Yeah. Right. It's grouping by. Cool. And it's decided service contact sounds a bit like customer calls. Right, good. Sorry, was there a question? Yeah? You? No. Sorry. Okay. But in order to get, so to get that last diagram that we saw, you saw the whole DAG thing. So all product with number of customer calls, number of purchases. Again, nothing in a database is called purchases, but it's going to work it out for us. And last purchase, I hope, when we generate it, it will work out that SQL for us. And there's just 2 small steps to do. It sort of has, yeah, I think so. Then we say, right, we want to use that SQL. You can actually manually type SQL in here, that's why you have to use that second step. You extract the parameters. This makes it really easy for moving through different environments, because the code that you've got here, every time there's a $, it's a parameter. And so you can remap it as you move it from development to test to blah, 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 to production. And then you describe the table that you want, so it's automatically working out the format of the table. And much like the other flow, you have to say what the key is. And that's, oh, sorry, and just do this. You can also view the data. So this has given us exactly the same as we got from the flow. And it's kind of patient, we say anything. You pay your money, you take your choice. Some people like doing the flows, some people like doing the AI. I'm not sure yet. Probably leaning towards the AI now. burning questions or coffee if you have any, okay? Thank you.